Okay, so what we're going to talk about is the proof of the Pythagorean theorem. I'm sorry, the proof of the law of cosines here, and the law of cosines is also sometimes called the generalized Pythagorean theorem. So we're going to start off with a triangle here, and we're going to label this side B. We'll label this side A, and well, let me redo that. We'll label this side A, we'll label this side B, and we'll label this side C. And what we'll have here is we'll go ahead and divide this up into two different triangles. And the reason we're doing this is because anytime we're dealing with the Pythagorean theorem, you know it needs to be a right triangle. So with this here, what we'll do is we'll go ahead and split this up into two different triangles. We'll call this part X and we'll call this part Y. And this altitude side here, we'll go ahead and give the name 0. And the reason that, the name Z. And the reason that we're doing this is because we want to basically use the Pythagorean theorem to solve for one of these sides by just giving variables, not giving anything else. So what we're going to do, let's go ahead and see. We have this angle theta here, and we want to find x. Well, we need to involve x. So x is the adjacent. Now, what trig ratio uses the adjacent, and also we can just say the hypotenuse, the adjacent and the hypotenuse. Well, that'd be cosine. We take cosine of theta is equal to the adjacent over the hypotenuse, which will be equal to x over b. We can imply here, and we'll say that cosine of theta is equal to x over b, which says that x is equal to b times cosine of theta. Okay? Now, that's just by doing a little algebra there. Next, if we want to find y, well, generally I know that this entire length here is c, and if I take away this x part, I'll be left with y. So we can say c minus x would leave me with y. And go ahead and put this into y, solve it for y. We get y is equal to c minus x here. All right, we'll basically just move y to the right hand side. We get y is equal to c minus x. Well, we can go a little bit further with this. What did we say x was? Well, we said x is right here, b times cosine of theta. So y is equal to c minus b cosine theta. Next, let's find z, because if we have y, we have x, and we have z, all we need to do is use the Pythagorean theorem to find a. As we already have z and we have y, we just use the Pythagorean theorem to find a. Or we can do the same thing for b. If we have x, we have z, use the Pythagorean theorem to find b. So from here, what we'll do is let's go ahead and find what z is equal to. Well, z would be, from this angle, would be the opposite. What angle involves the opposite in the hypotenuse? What trig ratio? Well, I'm looking at the sine trig function. Sine of theta is equal to the opposite. So what involves the opposite and the hypotenuse? That's sine. Opposite over hypotenuse, which we say the opposite is z and the hypotenuse is b, because the hypotenuse, right, b is right across, I was going to say right across the street, but directly across from b. So z over b. We can imply that z, give me a second, that z is equal to b sine theta, right? And all I did here, if I take sine theta is equal to z over b, and I just use a little bit of algebra to get solve for z, I'll be left with that there. Z is equal to b sine theta. And now what I have here is I have these all solved for, right? I have them all solved for. And generally what I want to do next is I want to use the Pythagorean theorem to actually find what this side A would be equal to. So if I want to go ahead and do that, find what side A would be equal to, I could use the Pythagorean theorem. I could just say a squared is equal to, since it's the hypotenuse, a squared is equal to z squared plus y squared. Using algebra here, using just substitution, a squared would be equal to, well, what did we say z squared was? Z squared is b sine theta, so we can just say b sine theta squared plus, substituting y in here, what did we say y was? C minus B cosine theta. Okay? And of course we have that squared there. Now we're just going to distribute. We have a squared is equal to, now since this is a single monomial here, what I'm going to do, I'm just going to distribute this to everything that's inside this parentheses, right? I'm not going to have to FOIL anything because it's not two binomials. Like this here is two monomials. We have a binomial here because we have it divided by, it's basically split up by this subtraction sign here. So this will be b squared sine squared theta plus c minus b cosine theta times c minus b cosine theta. And what we're going to do here, we're actually going to FOIL that out. So b squared sine squared theta plus c times c will be c squared, then c times that minus b cosine theta, that b added with this negative b cosine theta times that c. We'll be left with a minus 2bc cosine theta, and then this negative b times that negative b cosine theta will be plus b squared cosine squared theta. And from here we'll come down a little bit so we can finish simplifying. We'll get a squared is equal to, now let's look here, we can bring this b squared cosine theta over here with this b squared cosine theta, b squared sine theta, sorry, so we have b squared sine theta, sine squared theta. We'll just bring this plus b squared cosine squared theta with it, so we can potentially use one of our trig identities, and then we'll just have c squared minus 2bc cosine theta left. And now we'll factor out a b squared, and we'd be left with sine squared theta plus cosine squared theta plus c squared minus 2bc cosine theta. And then from here we'll take a squared is equal to b squared. Now I see something here, and it indeed is a Pythagorean identity, right? A Pythagorean identity that I see here. So what I'm gonna I know I can write this a little bit better. Give me 1 second here. The Pythagorean identity. Okay, the Pythagorean identity here, it says that sine squared theta plus cosine squared theta would be equivalent to 1, right? It's equivalent to 1. So from there, I'll just bring down this plus c squared minus 2bc cosine theta. Now, I have a squared is equal to b squared plus a squared is equal to b squared plus c squared minus 2bc cosine theta. And that's all I can do with this. And there we have our law of cosines. And the other formula is, this is just one solve for a squared. Now we have other ones that are solved for b squared and that are solved for c squared, and we'll get to those actual formulas in the next video. But this here is the proof of the law of cosines. Any questions? Maybe I went too fast or something, or didn't explain a part just right. You just put it in the comments below, or send me an email at justdoittutorial@gmail.com, or you can put it in the comments below and I will respond to them. Thanks.